All right. So I started recording. Let's talk about a new topic, that is loops. And this is the time of the semester when students find the material extremely hard. You should make sure that you understand everything that is going on, that you are thorough with everything that has happened so far. It is going to get more and more difficult now. The difficulty just rises very sharply now. Okay, so please bear that in mind.
Excuse me.
Yes.
When are the assignment solutions going to be posted?
Assignment. Yeah, I will post those. Yeah.
Okay.
Yeah. I'll try to do that this afternoon. I've been forgetting. Yeah.
Perfect. Thank you.
Okay. Yeah. Any other questions before we begin? Okay. Let's.
Did we have a class exercise today? Quiz before lecture. I mean,
Yeah, it will be the same format. We will have a class exercise and a lab.
no quiz. What about quiz before lecture?
A quiz?
Yes, the quiz before lecture.
I was also not able to
Oh,
access
I forgot
the before lecture
Yeah, neither was
quiz.
I.
I have emailed you too.
Yeah, sorry, I forgot to open it. I will just waive it. I will just give everybody full points. So sorry about that. That was accidental. Yeah, sorry about that. I'll still make it available. If you want, you can do it, but I will give everybody points. Okay. Yeah, sorry about that. All right, let's then talk about loops. Let me share the screen. So the new topic is loops. What are loops? Up until now, we have been talking about programming in terms of two types of statements. We started programming with Python, and the structure of our program has been like this. You write a statement, you write the next statement, the next statement. They all follow. This is physically what you see on the screen, right? Physically, you see one line after the other. And the first few programs that we saw in this class also had the execution follow this physical appearance. That is, if this was the first statement, if this was your second statement, etc., they executed in that order. So the physical appearance was also the logical execution. Then we decided that we don't always want to execute all the lines. We had if statements. If there was a condition, we wrote a condition here, we do something. Then we had things like elif, something, we had statements and so on. So these are called selections. If, elif, else, and so on. The idea of a selection is that you don't always execute all the statements. You choose to skip some of the statements and you select some other statements for execution. So not all the statements get executed. Some of them get executed, some of them don't get executed, right? So that is called selection. Now we are coming to a different type of statements called loops. This is called sequencing. This is called selection. And this is the third one, loops. So we had sequencing, selection, and now we come to loops. We have done this, we have done this. This is what is happening now, starting this week. What is a loop? We have a bunch of statements, and then what we are going to do is execute these statements repeatedly, one after the other. I mean, you execute all this, then again execute it, then again execute it, execute it, until we decide there is no more execution. So we execute these loops or these statements until some condition is not satisfied, or while some condition is satisfied, we continue to execute this. For example, if you want to print a simple example, print numbers 1, print 2, print 3. If you have statements like this will print 1, then 2, then 3. You could keep on writing more things. If you wanted, say, 1 through 6 to be printed, it is easy to write that. Print 4, print 5, print 6. But if you wanted 1,000 print statements, that is very hard to write. I mean, you can write it, but it will take a while. If you had 1,000,000 numbers to print, that would take a lot more time. So that is not a feasible, that is not practical way of doing things. So we don't want to do this kind of stuff. Instead, what we will do is we will write one statement, print a number, and then do this repeatedly by changing number. So we will write like this: while n is less than 1001, print n, n equals n plus 1, and we write n equals 1 here. What will this do? Let's see whether this will work. We set n to 1. So we have a variable n that is currently 1. Then we check whether it is less than 1001. If so, we print it. So we get 1 on the screen. So that is what the while loop does. You have seen this in the video, right? We write while and we put a condition. So this is very similar to if statements in the structure. Instead of if, we put while, that's it. So it's very easy to learn. But the meaning is very different. We still check a condition. You can write a condition just as you write conditions for if. You can use and, or, less than, greater than, all that stuff. So we have the word while, which means check this condition. If this condition is true, while this condition is true, as long as this condition is true, execute all these indented lines. Print n. N is 1, so we will be checking n against 1001. Of course, 1 is less than 1001, so we will be printing 1. Then we have the next statement, n equals n plus 1. So n becomes 2 now. What happens now is Python goes back and checks this condition again. 2 is less than 1001. So this condition is still true. So the while loop continues execution. It continues execution as long as the condition is true. So this will print 2. Then n is incremented to 3. 3 is less than 1001, it will print 3. Then n becomes 4. 4 is less than 1001, and so it goes. At some point, n will become 1000. As you can see, it will keep on increasing. When n is 1000, 1000 is still 1000 less than 1001. It will print 1000. Okay, so you will see, sorry, here, you will see 1000. Then n will become 1001. N is now 1001. 1001 less than 1001 is false. So the while loop exits. This is no longer true. This is a false condition now. 1001 less than 1001. So this is false. So while loop ends, control will go to the next line. You could have a print statement or nothing. It doesn't matter. If you put something like this, it will print end at the very end. That is the while loop. Questions? Anyone? Okay. So this is the third form of constructing, controlling statements. As we saw, we had a sequencing where we write statement after statement and they get all executed. Then we had selections, and then we have loops. In general, you can write any program, solve any problem using these 3 constructs. If you can write lines one after the other and execute them, and selectively execute lines and use repetition, you can solve any problem. There is a theorem that says that, but of course, that would be, you would need more handy things to solve things more easily, but this is necessary and sufficient. You need all 3 in general, but not every program needs, every problem needs all 3, but most problems would need all 3. I can't imagine a problem that doesn't need sequencing, unless it is a very trivial problem like print a line, that's, then you don't need any sequencing, you just need one line. But in general, you would need sequencing. And if it is any meaningful problem, you would need selections and loops. So you should become proficient at using all 3. Okay, so we have the while loop, and we write while exactly like this in lowercase. We put a condition here. As I said, this condition can be any condition, just like what you wrote for if statements. There is no difference. There is nothing new to learn here. Then you put a colon, just as you put for if statements. So this syntax, the grammar is very simple, very similar to if statements. And then you should indent your code, all aligned to the same column, and you can put your statements here. All of them get executed if this condition is true, provided they are in sequence. If you have if statements here, some of them will get executed, some of them will not. You can have loops here, which we will see later, but you can have loops and if statements and just about any Python statement within the loop. This is called the loop header. And this is called the loop body. Okay. Questions? All right. We will do one problem which you must pay a lot of attention to because it is going to be useful for your lab, and it also has some general approaches that would be very, very useful in your learning of computer programming. So let's look at a problem. The problem is this. I want to read a sequence of numbers okay. So I want to read a bunch of numbers, and let's say until 0. If you get 0, you stop. Then print the sum of all these numbers. So you need to read a sequence of numbers. So for example, 3, 2, -5, 8, 2, and then 0. So read a sequence of numbers until 0. So you have to read all this and stop at this point. Print the sum of all these numbers. How much do they add up to? 3 plus 2, 5. -5 is going to make it 0.
10.
8, 2. So it gives you 10. So the answer should be 10. The first number itself could be 0, in which case the sum would be 0. Right? So this is the problem. How do you solve this? You have to read a sequence of numbers until you get the number 0. And then you print the sum of all the numbers. So how do I do all this? So my rough thought would be like this. I need to read the numbers repeatedly. Until 0. Until, I mean, what I mean is until I get the number 0. And then here I will print the total. Okay. This is essentially the requirement. This is not really pseudocode, because this is, I'm not saying how to create the total or anything of that kind. So this is not pseudocode at all. This is simply saying, this is what I have to do. So I'm just writing in 2 lines what I need to do. But how do I create this total? How do I read the numbers repeatedly? I can't write I can't write input number into A, input number into B, and so on. If I write like this, I don't know how many numbers I should be, how many statements I should be writing. Because I could have 1 number, 2 numbers, 3 numbers. How many numbers? How many statements should I write? So this is not feasible. This is not practical. So what I have to do is something like a loop. So I need to read a number, and I need to do this repeatedly. So I need to write while the number is not 0. I'm trying to construct a loop. Read a number while the number is not zero, keep reading. So I have some ideas here, but this is still not quite right. What is not right about it? Of course, I'm not totaling the numbers or anything, so there is a deficiency in that respect. But there is another problem with this. The problem is that I'm checking if the number is not zero, but I don't have a number to check. This will crash. So I need to write read a number. I'm just sketching my thoughts here, not writing proper pseudocode. Read a number. Now I have a number in hand. And if that number is not zero, I will read another number. And if that number is not zero, I will read another number. This is inside the loop. So I will be repeating this as long as I don't have zero. The moment I get a zero, I will quit the loop and I will come here. That is the plan. Think about this. Look at this and see if you have understood it. It is crucial to understand this. Otherwise, the rest of the semester is pretty difficult. Going to be difficult. Any questions? So we are reading a number using Python input statement and all that. And we are checking, is that number zero? If it is zero, that is the end as far as the problem is concerned. So let me refine this a little bit. So instead of just writing read a number, I'm going to write read a number into n. Okay. And then I'm going to write while n is not equal to zero, read a number into n. So this is pseudocode, although it is still not all that useful. What am I doing? I'm saying read a number into n. So the user types in a number and I store that in n. If n is not equal to zero, I will again read a number. If that n is not equal to zero, I will read again a number. So this will keep on reading numbers one after the other until the user types in zero. The moment I get a zero from here or from here, I will stop executing the loop. I continue the loop only if n is not equal to zero. That could be because the first number is not equal to zero, or any of the succeeding numbers is equal to zero. At that point, I will quit. Do you follow this program fragment? Anybody who has difficulty with it, ask now, please. Okay. Now, what we still are not doing is adding up the numbers. So we still are not adding up the numbers. So we need to figure out how to add up all the numbers that we are reading in. We are reading in a number here. We are reading in lots of numbers here, potentially. We need to add them all up. Okay. How do you add up numbers? For this, you need to think about how you add up numbers in your mind if you didn't have a computer. Suppose you get numbers like 2, 3, 4. What are you doing when you are adding? You have to ask yourself, this occurs so natural to you, it is hard to kind of see what you are doing in your mind. And that is a challenge. What are you actually doing when you get a sequence of numbers and you are supposed to add them? Because if you can figure out how you are doing it, then you can translate that to pseudocode and to Python code and get a program. So what are we doing? We get 2, then we say, okay, the total is 2. Then we get 3, so total is 5. Then we get 4, the total is 9. So if you get 0 now, we know that there is nothing more, and we print, we say the total is now 9. But what are we actually doing? Well, when we get the first number, we are checking if it is equal to 0. If it is 0, then there is nothing more to do, because we are told the more I can stop when the number is 0. So when I read 2, I know that it is not 0. So I'm checking something like this, and I need to add that to my total. This is the first number, but I have to have a running total. I have to have that, which is initially 0. So when I get the 2, I'm adding to this running total and making it 2. When I get the 3, I add it to the running total and make it 5. When I get the 4, I'm adding that to 9. And when I get a 0, I'm quitting and I'm printing the running total. So if I want to simulate this in my computer program, I need a running total, which I will call total is equal to 0. This is called an accumulator. It accumulates information. This is a very simple accumulator. It just accumulates the total of all the numbers. So what I will do is I will initialize the accumulator before I read any numbers. And here I will add the new number to total. So this is the first step in accumulating the total. That is, have an accumulator and initialize it to 0. Then in the loop, add the number that you got to the total. So the total keeps building up. And once you get out of the loop, you can print the total. I ask that you understand this now. If you understand this well, you will be able to do the lab more easily. You would have learned an important technique, that is using an accumulator. This is a simple example of an accumulator. The same idea is used repeatedly in many, many contexts. So the construction of a loop like this is very handy. You will be able to solve a large class of problems, at least a few lines of code of a large class of problems, if you understand this now. Okay, it is, you have to understand it right at this time. So I don't mind answering questions, but you must understand every line of the pseudocode. I'm not kidding. You have to. When you have to build up something, you need to initialize something. Here we have to build up the total of a bunch of numbers. So the total has to be initialized. And when you don't have any numbers, the total is going to be 0, right? And this is another important technique. You read a number before you start a loop, and then within the loop, you again read a number. So you are reading a number here, then hitting the loop. And in the loop, the last thing that you are doing is read another number. Try to understand the form of this code. It is also given in the PowerPoint. So you can see the same code in the PowerPoint. But it's important to understand this. I don't mind spending a little more time on this, but it would be much more fruitful if you would ask some questions and I answer them.
What's the accumulator? Give me some bacon.
What is an accumulator? Is that your question?
Yep.
Okay, an accumulator is a variable that builds up something. For example, in this case, it is the total of a bunch of numbers. You can think of a list. For example, the list of students who register for a course, right? Initially, like the spring registration is going to start maybe tomorrow or something, right? So you have lots of classes offered in the university, and every class has 0 students in it, right? And as you folks register, these classes will build up, right? So for example, ICS 140 next semester, section 1 will have no students today. Tomorrow, a few students might register perhaps, and it will have just a few students in it. Then as students register, it will be building up. So that is an accumulator, a different form of accumulating. You're accumulating a list of students. So an accumulator is something that you build up to store information. It could be that you want an accumulator to add up a bunch of numbers and then find the average, perhaps. Or it could be, as I said, a list that you create. Or it could be a string that you build up to display. It could take many forms. But the idea is still the same. You initialize the accumulator and you build it up repeatedly in a loop.
Thank you.
Yeah, you may need multiple accumulators in a problem, and they may take different forms. So you might have a list, you could have a total, you could have something else, a string buildup, and so on and so forth. So it accumulates, it builds up. That is the idea of an accumulator. So an accumulator has an initialization and a place where it gets modified. Please understand the structure of this pseudocode. Anyone else? Okay. The Python code would be like this: total equals 0, number equals int input if you want integers, and then while all lowercase, while number is not equal to 0, total you have to indent this code just like if statements, total plus number, and print, sorry, not print, number equals int input, enter a number. I don't have too much space here. And then that is the loop. At the end of the loop, I will come here and print total. Okay. Now, you can see that I'm checking if number is not equal to 0. So it is important that number be given a value before I hit the loop. Otherwise, this will crash. If there was no statement like this, number equals int input, I wouldn't have a value for number and Python will crash your program. And also, if you don't change the value of number, if you don't give a chance for number to change, this loop will keep on repeating, and that is called an infinite loop. We don't want an infinite loop. Okay. Any questions before we conclude?
So this is the Python way of writing.
What is the Python way of?
Oh, this is like how you do it for Python code.
This is the Python code, yes.
Mhm.
Yeah. This is the Python program that will read a sequence of numbers and then print the total of those. Later on, if you want to print the average, you can do that. Can somebody suggest what we need if you wanted the average of all these numbers? If you wanted the average of all these numbers, not just the total, what change should you make?
Don't you also need a counter to keep track of how many numbers it's
Correct. You need a
adding in?
counter to check the number of, to accumulate the number of numbers. So you need one more accumulator. Counter equals 0, and counter should be equal to counter plus 1 here. And then you need to divide total by counter. But then at that point, you need to check if counter is 0 because you don't want division by 0, right? So that's a very good answer. Anyone else having any questions on this? Okay, if that is the case, I'm going to stop sharing, stop recording. And